Welcome back to board preparation series for class 10th on my channel Mathify with Meenakshi. Today in this video we'll discuss topic wise important questions from chapter number 11 area related to circles. But before moving to questions you should know these terms sector, arc and segment of circles. So let's see them quickly. First, segment. Segment is a region enclosed by a chord. This one is chord and arc of a circle. If it's less than half, you can say minor segment. If it's more than half, you can say major segment. Now, what is arc? Arc means part of circumference. That means boundary. You know, circumference is boundary. So, part of that boundary. If it's again less than half, you will say minor arc. If it's more than half, you will say major arc. As you can see in figure, let's move to sector. What is sector? We are already familiar with slice of pizza. You know that shape, that's sector. Sector is again the part of circle, but here the region enclosed by two radii. As you can see, this one and this one, two radii and arc of a circle. If again it's less than half, then you can say it's minor sector. If it's exactly half, semicircle. If it's more than half, then major sector. Now let's move to the important formulas. As you can see, I have written four important formulas for you. Let's discuss them one by one. First, area of minor sector. So first I will draw figure for you. This is a circle with center O and radius R. Now, if you have to find the area of this sector, how you can find that? You should know this angle theta. Then the formula is theta by 360 degree into pi r square. But in case you have to find the area of this remaining sector, that means area of major sector, you will simply subtract this area of minor sector from pi r square. Let's move to second formula, length of minor arc. Again, I will draw one circle for you. Suppose this is a circle with center O and radius R. If you have to find this length, that's length of minor arc, how you can find that? You can simply use formula theta by 360 into 2 pi r. This time you will write 2 pi r because we have to find the length of part of circumference. And what if I have to find the length of remaining arc? You will simply subtract this length of minor arc from circumference, that is 2 pi r minus length of minor arc. Let's move to third formula, area of segment. So for area of segment, it's very important because how you will get area of segment? You know this, if this is a sector and this is a triangle, then the remaining portion is your segment. So to get the area of segment, we have to subtract area of this triangle from area of sector. That means segment is area of sector minus triangle. Now how I can find the area of triangle? Just learn this formula that if radius is known to you and theta, you can simply use the formula half r square sine theta. This we derived using trigonometry ratio. So you can directly learn this. But this holds only if theta is 90 degree or less than 90 degree. But if your theta is more than 90 degree, especially if it's 120, because in your syllabus 120 is there, then you have to use this formula, that's r square sine theta by 2 cos theta by 2 instead of half r square sine theta, because you don't know the values of sine more than 90 degree. Now let's move to last formula, but it's important that whenever you have to find either the area of minor sector or the length of minor arc, and one thing is given to you, you can directly use this relation that your area of sector is equal to length of arc into radius divided by 2. Now let's move to questions. First topic, circumference and area of a circle, one of the easiest topic. First question, difference between circumference and radius of a circle is 37. We have to find circumference of the circle. That means circumference minus radius is 37. Now we can take r common, so we are left with 2 pi minus 1. Let's put the value of pi. Pi is 22 by 7. So 2 into 22 is 44 by 7 minus 1 is equal to 37. Let's take the LCM here. So it will give you 44 minus 7 by 7 is equal to 37. What is 44 minus 7? It's 37. So we can cut that. Now we're left with r by 7 is 1. That means your r is 7 centimeter. But we have to find circumference. Now you know that your circumference is 37 plus r. So you can write my circumference is 37 plus r. And that will give you 37 plus 7 is equal to 44 centimeter. B option. Now let's move to second question. In second question, you have to find the area of the largest triangle that can be inscribed in a semicircle of radius r. So first draw a semicircle of radius r. This is your center and this is your radius. So we have a semicircle. We have to find the largest triangle that can be described in this. So how we can find? We know area of triangle is half into base into height. Here your base is 2r. How we can find the maximum height? You know that your height is always perpendicular. And what is this? It's only radius. Yes, distance from center to circumference is radius. So largest triangle is this one. You can say half into 2r into r. If we'll cut 2 and 2, we'll get r square is the area of largest triangle that can be inscribed in a semicircle. Let's move to question number 3. If the areas of two circles are in the ratio 4 is to 9. So I'm writing pi r square by pi r square is given to you 4 by 9. We can cut pi and pi. So we are left with r square by r square is equal to 4 by 9. From here we can say the ratio of their radii is, you can take the square root of 4 by 9. That's 2 by 3. We have to find the ratio of perimeter. Now what's the formula of perimeter? That's circumference 2 pi r by 2 pi r. We can cut 2 to pi pi. We are left with r by r. And that is nothing but 2 by 3. A option. So from here you should know this thing. The ratio of radii and the ratio of perimeter is same, and the ratio of area is square of ratio of radii. Now let's move to fourth question. If a circular grass lawn of radius 35 meter and has a path of 7 meter wide running around it on the outside, then find the area of the path. So it's given that we have a circle whose radius is 35 meter and we have a path of width 7 meter. From here to here it's 7. That means small r is 35 and let's take capital R as 35 plus 7, 42 meter. That's the radius of outer circle. We have to find the area of path. We know what is area of path? It's area of outer circle minus area of inner circle. That means pi capital R square minus pi small r square. This will give you area of path. What you can take common from here? We can take pi as common and we are left with r square, capital R square, that is 42 square minus 35 square. Pi is 22 by 7. And you can use one identity here, a square minus b square, that is a plus b and a minus b. So what is a plus b? 42 plus 35, that is 77. And 42 minus 35, that's 7. 7, 7 you can cut. And what is 22 into 7? 1694 meter square. So this is the answer of area of path, C option. Now let's move to next question. Question number 5. If the radius of a circle is diminished by 10%, then the area is diminished by what percent? So let's divide in two cases. First original and then new. Let original radius be r only. Then your new radius is r minus 10% of r. As given, it's reduced by 10%. That means r minus 0.1 of r. You can say 0.9 of r. You can do this mentally too. Now, what was our original area of a circle? That's pi r square. And what is the area of new circle? Again, pi r square. But now r is 0.9 of r. That means pi into 0.81 r square. You can say 0.81 pi r square. They are asking diminished by, that means decrease percent. You should know the formula of decrease percent. That is difference 1 minus 0.81 pi r square is 0.19 pi r square upon initial, that is pi r square into 100. That's the formula for decrease percent. You can cut pi r square and pi r square. 0.19 into 100 is 19%. So your area is reduced by 19%. Let's move to sixth question. If the sum of the circumferences of two circles with radius r1 and r2 is equal to the circumference of a circle of radius r, what's given? 2 pi r1 plus 2 pi r2 is equal to 2 pi r. Then which one is true? You can simply take 2 pi common, r1 plus r2, here 2 pi r. If you will divide the whole equation by 2 pi, you are left with r1 plus r2 is equal to r. That means A option. Let's move to next question. Now let's move to question number 7. The short and long hands of a clock, you should know short hand means hour hand and long means minute hand, are 6 centimeter and 7 centimeter long. It means they are radii. Find the sum of the distance traveled by them in 2 days. What's the meaning of 2 days? That's 2 into 24 hours. You can say 48 hours. In 48 hours, you know that your hour hand will complete how many rounds? Yes, 4. So you can say distance traveled by hour hand is 4 into 2 pi r. That means 4 into 2 into 22 by 7 into 6. And that's 8 into 22 into 6 by 7. You can write approximately it's 150.86 centimeter. It's approx. Let's move to minute hand now. Distance traveled by minute hand is, it's 48 into 2 pi r because we have 48 hours. 48 into 2 into 22 by 7 into capital R, that is R. 7. 48 into 44, and that will give you 2112. 2112 centimeter. Now we have to find the total of these two. But as you know that the one is approximate, that's 150.8. So you will get the approximate answer. That is, let's write total distance. If you will add these two, this one and this one, adding 1 and 2, it's 262.86 centimeter. Again, this is also approx. Now let's move to question number 8. Assertion and reason based questions. First part, assertion. A track is in the form of a circular ring. That means like this. It's given that outer circumference is 396 meter and inner circumference is 352 meter. Then width of the track is 14 meter. Width means this one. It's 14 meter. So let's check it's true or not. It's given 2 pi rs 396 and 2 pi small r is 352. Now you know what is width? Width is difference of radius r minus r. So let's check that. If we'll take the difference of circumference, what we'll get? You can take 2 pi common, r minus r, and this is 44. Now 2 pi means 2 into 22 by 7 r minus r is equal to 44. You can cut 44 and 44. Now, what's your r minus r? R minus r is 1 into 7, that is 7. And this is width. So, r width is 7, but they said 14. That's why assertion is false. That means no need to check your reason. Correct option is D. Assertion is false and reason is true. Because we don't have any option where both are false. Let's move to next question. Assertion. If the circumferences of two circles are in the ratio 4 is to 5. That means 2 pi r by 2 pi capital R is 4 by 5. From here, what you can say? That the ratio of the radii is 4 by 5. Then they are saying that the ratio of area is 16 is to 25. Let's check. Pi r square by capital pi r square. That means you can cut pi and pi. R by r square, that is 4 by 5 whole square. You can say 16 by 25. Yes, it's true. In beginning also I told you that the ratio of radii is same as ratio of circumference, but area is square of their ratio. Now let's see reason. If the circumference of two circles are in the ratio of C1 is to C2, then their area is in the ratio of roots. No, as I told you, area will be square of these two. So this is false. That means which option is true? C. A is true, but R is false. Now let's move to next topic, area of a sector. First question, area of a sector OAPB is 5 by 18 of area of circle. Find the value of degree of measure, that means you have to find theta, and find the area of sector. And radius is given to us 21 centimeter. Let's write that area of sector, that is theta by 360 into pi r square is means equal to 5 by 18 into area of circle. We can cut these two. So, and we can also cut 18 and 360. We are left with theta by 20 is equal to 5. That means if you do cross multiplication, your theta is 100 degree. Now let's move to second part of the question, that you have to find area of sector. Now what's area of sector? Theta by 360 into pi r square. So I'm writing directly 100 by 360 into pi, that is 22 by 7 into r square, 21 into 21. Now we can cut that. 7 into 3, 3 into 120, 0, 0 you can cut. Here it's 6, 5, then with the table of 3, it's 7, it's 2, then 2 and 22, 11. So we are left with 5 into 77. That is 385 centimeter square. Question number 2. A sector of a circle with central angle 60 degree, that means it's theta, has an area 231 centimeter square. Find its radius. So we have to find radius. So let's use the formula. Area of a sector is equal to theta by 360 degree into pi r square. Theta is 60 by 360 into 22 by 7 into r square. Area is 231. Let's cut this. It's 1 by 6. Here if you cut with the table of 2, 11 and 3. Now you can cut 11 and 231. It's 11 to 22 and we are left with 1. That's 21. Now what's your r square? If you will transpose 7 and 3 that side, it will become 21 into 7 into 3. That is also 21. 21 into 21. That means your r is 21 centimeter. Now let's move to third question. Area of sector of angle P and radius capital R is, we know the formula, that's P by 360 degree into pi r square. Now just see the options. P by 180 into 2 pi r, no. P by 180 into pi r square, no. P by 360 into 2 pi r, no. But here P by 720 into 2 pi r square, yes, it will cut this with the table of 2. You will get the same answer. So answer is D. Let's move to fourth question. The area in centimeter square of a sector of a circle of radius 21 centimeter cut off by an arc of length 22 centimeter. That means here the length of arc is given to you L and here radius is given to you. We have to find area. I told you one formula that we have a direct relation that A is LR by 2. Just use this formula. L is 22, R is 21 by 2. We'll cut this 11 into 21. That means 231. C option. So this formula is very important. Now let's move to next topic, length of an arc. First question, the minute hand of a clock is 84 centimeter long. That's your radius. Find the distance and the area covered by the tip of minute hand from 10:10 to 10:35. This time will give you angle. We travel for 25 minutes. That means 1 minute is 6 degrees. So 25 into 6, that's 150 degrees. So this is your theta. You know your theta, you know r. One time you have to find distance. Distance means length of an arc. So we'll use the formula of length of an arc, and area is area of sector. So let's write distance is equal to theta by 360. That is 150 by 360 into 2 pi r, 2 into 22 by 7 into r. And here you will write area. Area is theta by 360 into pi r square. That is 22 by 7 r into r. We can cut here 7 and 84, it's 12. 12 and 360, it's 30. And 30 and 150, it's 5. So 44 into 5, that is 220 centimeter. Distance, let's find area. Again 7 and 84, 12. 12 and 360, 30. And this is 5. Here we are left with again 22 into 5 into 84. That's 110 into 84. 924 and 0 centimeter square. That's it. Let's move to question number 2. Question number 2. Find the perimeter of the quadrant. See carefully, radius 3.5 centimeter. You should know that quadrant should is 1/4 of a circle. That means here it's 90 degree. So for perimeter, what you will do? Its radius is 3.5 centimeter. This side also it's a radius 3.5 centimeter. You will add length of an arc plus r plus r. Most of the students forget this r. It's a perimeter, so you will add these two also, r and r. And this is length of arc. So we'll add all three. Length of arc is again 90 by 360. Here theta is 90 in quadrant. 90 by 360 into 2 pi r. 2 into 22 by 7 into 3.5 can be written as 7 by 2 plus 3.5 plus 3.5. You can cut 7 and 7, 2 and 2, and this is 1/4. We can further cut this. So it's 11 by 2, that is 5.5 plus 3.5, 3.5 is 7. Yes, and that will give you 12.5 centimeter. Let's move to next topic, area of segment. Now, we have to find area of segment. As I told you that for area of segment, we have to always subtract, shaded region is here segment, area of sector minus area of triangle. So here sector, if you will see carefully, that's a semicircle. So you can say area of semicircle minus area of triangle. That's area of triangle RQP. And that's a right angle triangle. So for area of semicircle is half of pi r square minus area of right triangle. So you know it's 90 degree here. So you can simply multiply base and height. No need to use that formula, half of r square sine theta here. Now half into 22 by 7. Now just think, what is your r? How I can find this r? This RO or OQ? How I can find this? It's a right angle triangle. You can use Pythagoras theorem to find your RQ. That is square root of 24 square plus 7 square. 576 plus 49. That is 625 and that is 25. If you know the Pythagorean triplet, you can directly write that's 25. So R is 25 by 2 because that's a diameter 25. So I can write 25 by 2 into 25 by 2 minus half into base into height. Base and height are 24 and 7. Just cut this. Here also we can do cutting. It's 11 and rest we can't cut. So here 25 into 25 is 625 into 11 by 7 into 4, that's 28 minus 12 into 7, that's 84. Now if you will solve this, what you will get? You will get 161.55 centimeter square. Just take the LCM. Okay, let's move to next question. Area of shaded region again it's a segment. As you can see, it's segment. For segment, you will see write area of sector minus area of triangle. This time your theta is 120 degree. So when it's more than 90, I told you how you can find the area of triangle. You can simply write r square sine theta by 2 cos theta by 2. Okay, so we'll use this formula for area of triangle. Area of sector is easy. That's 120 by 360 into pi r square. That is 22 by 7 into 21 minus r square. That is again 21 into 21 sine theta by 2. That's sine 60 cos 60. You can take, if you want to take 441 common, just to save your time. So I'm taking 21 and 21. That's 441 common. So I'm left with, if you cut this, it's 1 by 3. So 22 by 21 minus, what is sine 60? That's root 3 by 2. And cos 60 is sine 30. That's half. So that is 441 by 22 by 21 minus root 3 by 4. So now you can solve this on your own. Just leave your answer in root 3 only because the value of root 3 is not given. If they will give you root 3 as 1.73, then you have to solve it further. I'm writing the final answer. That is 21 by 4, 88 minus 21 root 3 centimeter square. Now let's move to third question. It's given a round table has 6 equal designs. That means it's a segment. So we have 6 segments as shown in figure and radius is 28 centimeters. So let's draw the radius first. Here radius is 28 centimeter. Find the cost of making the designs at the rate of 0.35 per centimeter square, and here you have to use root 3 as 1.7. Now what is total area then? Total area is 6 into area of one segment. That means we can say 6 into area of sector minus area of triangle. And what is the formula of area of sector? You know, theta by 360. For that we need theta. So if we will join all the radius, you will notice that this hexagon have 6 congruent triangles. Yes, so we can find theta. What is theta? Theta is 360 is divided in 6 parts. So you can say 60 degree. Did you observe something? If this is 60, as these two are radii and angles opposite equal sides are equal, so using ASP, you will get that these two are also 60. That means we have this triangle as an equilateral triangle. So while finding the formula of area of triangle, you can simply use area of equilateral triangle formula. So let's write the area of sector first. Theta by 360 into pi r square. And r is 28. So you can write 28 square, because we'll take that common, so I'm writing 28 square minus here root 3 by 4 into, you know the formula of area of equilateral triangle, root 3 by 4 into side square, and side is 28 square. Now this is 1 by 6. I'm taking 28 square outside, so we are left with 22 by 7 into 6, you can say 42 minus root 3 is 1.7 by 4. Yes, you can cut this, it's 11 by 21. Now 6 into 28 square. I told you the trick of 28 square in one of my YouTube video. 8 square 64, write in 2 digits, and then 2 square it's 04, write in 2 digits, and then you have to leave this box and just multiply 2 into 8 into 2. That is 2 into 8 16, 16 into 2 32. 4 8 7. We have to simply add that. So we have 784 into 6. Just multiply this with 6. What you will get? If you multiply with the 6, you will get 4704. Yes, let's write that. 4704. Now what is 11 by 21? If you will solve that, you will get somewhere around 0.524 minus 1.7 by 4, that is 0.425. Just leave it here, because if you realize that here you have to find the cost, and for cost you have to multiply with 0.35. Okay, so I'm writing this as it is. Just multiply this 0.35 to get the final answer. So if you will solve, what you will get? Somewhere around 162.9 approx, you can say. Okay, now let's move to next topic, area of shaded region. In figure, two concentric circles with radii 21 centimeter and 42 centimeter. So this smaller one, that's OC, is 21 centimeter, and the bigger one, OB, you can say it's 42 centimeter. You have to find the area of shaded region, and it's also given that angle AOB is 60 degree. If you notice something, how we can find the area of shaded region? You can say it's looking like a ring, but something is missing. This one we have to subtract from ring. So first let's find the area of ring. How we can find the area of ring? That's area of outer circle minus area of inner circle. I can write capital pi r square minus small pi r square. You can take pi common, r square minus r square, that is 42 square minus 21 square. Now you know you can simply use the identity here, a square minus b square. So I'm using that. Pi is 22 by 7. Just one time add them, 42 plus 21, and one time subtract them. When you will add, you will get 63, and when you subtract, you will get 21. So that's 7 into 9. So your answer is 4158 centimeter square. This is my area of ring, but I don't need this dotted part. So I will write area of dotted part. I'm writing for you. I have to remove this, subtract this from my answer 4158. That's area of bigger sector minus smaller sector. Bigger sector minus area of smaller sector. So just use the formula here. Theta is same, so I'm writing 60 by 360. And even pi is same. Just take that 2 common. We are just different as r square. So you can write 42 square minus 21 square. Again, we'll use the same formula of a square minus b square. First cut this. So we're left with 11 by 21. And 42 plus 21 is 63. And 42 minus 21 is 21. You can cut this 21 and 21. So 11 into 63. That means 693. So this is your area of dotted part. And we have to subtract this because we don't need this part. So final answer, area of shaded region is 4158 minus 693. And that is 3465 centimeter square. So we're done with this question. Let's move to next question. ABCD is a trapezium where these two lines are parallel, and what is given? AB is 18 centimeter, DC is 32 centimeter, and the radii of this, that means it's 7 centimeter. All the sectors are same because radius is 7 centimeter for all. And what is given? That the distance between them, that's its height. Height is 14 centimeter. We know how we'll get the area of shaded region. For area of shaded region, we have to simply subtract the area of 4 sectors from trapezium. So I'm writing area of trapezium minus area of 4 sectors. But all the sectors are not same, huh? Because we don't know their angles. So I'm writing area of 4 sectors. You can't write 4 into area of 1 sector. Now area of trapezium, we know the formula, half into B1 plus B2 into H. Here we have two bases, parallel ones. And for this, you can write, if you will take these angles as theta 1, theta 2, theta 3, and theta 4. So you can write, you know the area of sector is theta by 360 into pi r square. Pi r square is same for all, so I'm taking common. You are left with theta 1 plus theta 2 plus theta 3 plus theta 4 by 360. Yes, because the area of sector formula is theta by 360 into pi r square. Pi r square is same. Even you can take 360 common if you want. Okay, now half into bases are 18 plus 32 and height is 14. Minus your pi is 22 by 7 into radius, that's 7 into 7. Now what is the sum of theta 1 plus theta 2 plus theta 3 plus theta 4? You know it's a quadrilateral. So by ASP of a quadrilateral, it should be 360. So this becomes 1. So whenever angle is not given to you, just see, can we use ASP there? So here we can use ASP. Now just cut this. Now you can cut 2 and 14 also. What is 18 plus 32? That's 50 into 7 minus 22 into 7. Here you can take 7 common, or you can solve directly. I'm solving directly. 15 into 7 is 350 and 22 into 7 is 154. So answer is 196 centimeter square. Let's move to next question. Question number 3. ABC is a square of side 14 centimeter. All the sides are 14 and it's a square 90 degree. Now, how will get this area of shaded region? Just see this figure carefully. If you will divide your square like this. First, I will get this area, that is x and z. How will get it? This? It's given that O is the center, okay? So both the circles are same. Now, first I will find the area of xy. How will get this area xy? Just see carefully. Yes, if I will area of x plus y is area of square minus area of two semicircles. That means area of circle, you can say simply, minus area of circle. Now area of square is side into side. You can say 14 into 14 minus area of circle is pi r square. That means 22 by 7. And what is r here? See, 14 is your diameter. So r is 7 centimeter. So you can write 7 into 7. 14 into 14, 14 square is 196 minus, you can cut 7 and 7, 22 into 7 is 154. So that's 42 centimeter square. If you observe this thing, that similarly you can find the area of that W and Y, because that's the same thing. Here also you have to subtract the area of circle from square. So I will not calculate this because they are same. So you can write similarly area of W plus Y is 42 centimeter square. So your total area is 42 plus 42, that's 84. 84 centimeter square. Now let's move to next question. We have to find the area of shaded region, and it's given radius of circle is 6 centimeter and side of a triangle is 12 centimeter, and it's an equilateral triangle. We have to find area of shaded region. What we can do for that? Just see the whole figure first. That it's triangle plus circle. So first we'll add area of equilateral triangle and circle. When you will add this, you will get 2 times this portion. So we have to subtract this 2 times because we don't need that. So we'll subtract from here 2 times area of sector. And because it's an equilateral triangle, so you know this angle is 60 degree. So let's do this. Area of triangle. It's equilateral triangle. You can write root 3 by 4 into side square. And what's the side of an equilateral triangle? It's 12. Then plus area of circle. Circle is pi r square. Here it's written you have to use pi as 3.14. 3.14 into r square. And what's the r? It's 6. Then you have to add this and subtract twice of area of sector. That's 60 by 360 into pi r square. Again pi is 3.14. R square and your r is 6. Okay, now can I cut something here? Yes, you can cut this. 3 into 12 is 36 root 3 and root 3 is 1.73. That is given to us. Plus 3.14 into 36. Then we have to subtract. This is 1 by 6 and we can cut 6 and 6. That means you are left with 2 into 6, 12 into 3.14. This we have to subtract. So what we'll get if you will solve this? 36 into 1.73, that is 62.28, plus 3.14 into 36, that's 113.04. You can check your answers. Minus 12 into 3.4, and that is 37.68. So 175.32 minus 37.68. So your final answer is 137.64
centimeter square. Let's move to next question. Again, we have to find the area of shaded region, but this time we just need this portion. How we'll find that? It's very easy. You will simply write area of bigger sector minus area of smaller sector. Bigger sector minus area of smaller sector. Theta is same for both the cases, so you can take 40 by 360 and pi common. And in bracket you can write r square minus r square. Capital R is 14 square and here 7 square. As I told you, whenever we have r square minus r square, that is a square minus b square, you can simply use the identity. So I will use identity for that, but for that, first I can cut that. So 22 by 9 into 7, that is 63 into, one time you will add and one time you will subtract. Now 22 by 63 into, what is 14 plus 7? That's 21, and 14 minus 7, that's 7. You can cut there, it's 1, and here it's 3. So answer is 22 into 7, that is 154 by 3. And your answer is 51.33 centimeter square. Now let's move to next question. In this question, it's given that ABC is a right angle triangle that's right angled at B, and AB is 14 centimeter and BC is 24 centimeter. And all the sectors have radius 7 centimeter. Let's take these angles as theta 1, here theta 2, although we know it's 90, and this one as theta 3. Now we know if we want to find the area of shaded region, then it's equal to area of triangle minus area of 3 sectors. I'm not writing 3 into area of sector because all the sectors are different. Now, we can find area of triangle directly here, half into base into height. And what's the formula for area of 3 sectors? It's theta 1 by 360 into pi r square plus theta 2 by 360 into pi r square plus theta 3 by 360 into pi r square. But as we know that here pi r square is same, so I am taking that outside, pi r square, and in bracket we are writing theta 1 plus theta 2 plus theta 3 by 360. Now, what is half into base into height here? Half and base and height are 24 and 14. And here we can cut this 7 and 7. So we are left with 22 into 7. That's 154 into. Did you realize something? What's is theta 1 plus theta 2 plus theta 3? Using ASP of a triangle. Using ASP of a triangle, we know that sum of all angles the triangle is 180. So I can write 180 by 360. That means it's 2, 1 by 2. And you can cut this 77. Here also you can cut 12 into 14, that's 168 minus 77, and that is equal to 91 centimeter square. So this is your final answer. Now let's move to next question. Here it's given that ABCD is a square of side 7 centimeter, and because it's a square, all angles are also 90 degree. So you can mention that too. Now, just divide this into equal parts. So whenever we have to find the area of leaf, just divide that into equal parts. Now, just did you observe something here? That if you will take this one, DQBC, what is this DQBC? It's a quadrant. So if you will subtract triangle from quadrant, what you will get? If I will subtract from this whole quadrant, if I will subtract this triangle, what I will get? I will get area of this part. This part, that means half of leaf. So for that I have to simply subtract area of triangle from quadrant, and then I will just multiply it with 2 to get the area of leaf. So let's do this question. What is the formula of area of quadrant? Area of quadrant is, what is area of quadrant? That's 90 by 360 into pi r square. 22 by 7 and r square is 7 into 7. Minus area of triangle. Area of triangle is, here it's a right angle triangle. Simply say half into base into height. That's half into 7 into 7. It's 1 by 4. If you will cut this, you'll get 2. You can cut 7 and 7 also. Now it's 77 by 2 minus 49 by 2. Yes. What is 77 minus 49? That's 28 by 2. So answer is 14 centimeters square. But we have to find full leaf, so I will just simply double that. So area of shaded region is twice of this. You can say twice of 14, that's 28 centimeters square. Let's move to next question. Now let's move to next question. Here it's given that AVDC is a quadrant where D is this point and radius is 14 centimeter of this quadrant. As it's a quadrant, so here it's 90 degree. And it's given that with this BC, we have one semicircle. That means BC is the diameter of that semicircle. So can you tell me the radius of this semicircle? Yes, because it's a right angle triangle, you can use Pythagoras theorem. So using Pythagoras theorem, we get BC is square root of 14 square plus 14 square. Whenever we have the situation, you can directly write 14 root 2. Whenever you like 6 square plus 6 square, 6 root 2. 8 square plus 8 square, 8 root 2. You can write directly. Okay, so it's 14 root 2. Now, what's the radius? That means it's 14 root 2 by 2. You can say 7 root 2 is radius of that semicircle. So I'm writing here 7 root 2. Now, how will get the area of shaded region? First, see the whole figure. That means area of triangle plus area of semicircle. That's the area of whole figure. This is the area of whole figure. From here, we have to subtract this quadrant because we don't need that. So area of quadrant. Now, what is area of triangle? Half into 14 into 14 plus area of semicircle is half of pi r square, where r is, see carefully, 7 root 2. 7 root 2 into 7 root 2. And then we have to subtract quadrant. For quadrant, it's 90 by 360 into pi r square. That's 22 by 7 r square. R is 14 for quadrant. So 14 square. Okay, let's cut this. It's 1 by 4. Here you can cut. It's 2 and 11. And you can cut this 2 and 7 with 114. Similarly, here you can cut. It's 7. Here it's 11 and 7. Now, if we'll take 7 outside, that means common. What you're left with? Here 14 plus. Here root 2 into root 2 is 2. 2 into 11, that's 22. Minus 11 into 2, that's 22. 7 into 14, that's 98 centimeter square. Now let's move to next question. A horse is tied to a peg at one corner of a square-shaped grass field of side 15 meters. So let's write this. Side of this square field is 15 meter. Because it's a square, this angle is 90 degree. And it's also given that the length of that rope is 5 meter. This much is 5. In first part, we have to find the area of that part of the field in which horse can graze. That means this much. And that part is area of quadrant. So that will be equal to 90 by 360 into pi. Pi we have to use here 3.14. So you have to see this carefully. If it's not mentioned, you can always use 22 by 7. R square, and R is 5 square. That means it's 1 by 4 25 into 3.14 by 4. So your answer is 19.625 meter square. Now for second part, what do you have to do? The increase in the grazing area if the rope were 10-meter long instead of 5. Now if the rope is 10-meter long, suppose it's still here. So you have to find increase in area. That means you have to find the difference, this one. Now I will find the area of bigger sector. That's 90 by 360 into 3.14 into 10 square. So area of bigger sector. And 3.14 into 10, you know it's 314. 314 divided by 4. That's 78.5 meters square. We have to find increase in area. So we'll subtract that and get our answer. 78.5 minus 19.625. So what's our answer? Answer is 58.875 meter square. Okay, let's move to next topic. That's hertz. So I've included two questions of hertz. Let's see. First question. The regular pentagon is inscribed in a circle with center O of radius 5 centimeter. Actually, it's very easy if you will see carefully, because if you will add this segment, this triangle, you will get one sector. So simply we have to take twice of area of sector. And it's a regular pentagon, so both the sector has are same. Twice into theta by 360 into pi r square. R is 5. But what about your theta? Just see carefully, as I told you in regular hexagon also, that here it's divided in 5. So if you want to find theta, it's divided in 5 triangles. So that means 360 divided by 5. That is 72 degree. So your angle is 72 here. 2 into 72 by 360 into pi r square. Here you have to find the answer in terms of pi. So you will keep it like this only, 25. Now it's 1 by 5. You can cut this 5. 2 into 5 is 10. So answer is 10 pi centimeter square. So read the question carefully, because in this question you have to find only in terms of pi. Let's move to last question. Find the area of shaded region. Just see this figure carefully. Can I join like this? It's a square inside. If you will see carefully. Now total side is 14. 3 and 3 we can remove. So that means from here to here, how much we have? That's 14 minus 6. You're left with 8 centimeter. Now we have to divide 8 in such a way so that it will be symmetrical. That means we can say here we have 4 above the line, and below the line also we have 4. This is 2, this is 2, this is 2, this is 2. Yes, that means that this semicircle has radius as 2 centimeter and this square is of side 4 centimeter. Now the question is very easy. What we have to do? We have to simply subtract this design from bigger square. So area of bigger square minus area of smaller square plus, as I told you, it's a symmetrical design. That means 4 times area of semicircle. That will give you twice of area of circle. Now, area of bigger circle is 14 into 14, side square, minus area of smaller square, that's 4 into 4, plus twice of area of circle. Now we know area of circle is pi r square. So you will take 2 into 22 by 7 into r square, that's 4. You can write 196 minus 16 plus 44 into 4 by 7. That's 196 minus 16 plus 25.12. You can write 196 minus 16 minus 25.12, because if it's a minus outside, you can change the sign of all the terms inside the bracket. This is 180 minus 25.12, and that will give you 154.88 centimeter square. That's your final answer. Now, this is your think and crack task. Solve this and drop your answer in the comment box. I have carefully selected these questions so that you can score good marks in your boards. If you like this video, don't forget to like, share, and subscribe to my channel Mathify with Meenakshi. Thank you, everyone.